Hello wonderful people, it's Medicosis Perfectionalis. Welcome back to my physics playlist. In previous videos we had an introduction to physics and we talked about the differences between scalars and vectors. As for today, we'll learn about how to split a vector into its components, the horizontal component and the vertical component, or x and y. We will learn about the addition of vectors, the subtraction of vectors, and the multiplication of vectors, and how you can use the right-hand rule to determine the direction. Recall that a vector is an entity that has a magnitude and a direction. This video has more than 10 questions with answers, so grab a pencil and let's see how many questions you'll get right. Click the like button, click the subscribe button, and let's get started. Please watch the videos in this physics playlist in order for maximum understanding and retention, not to be confused with mechanical retention. Remember last time we talked about the difference between scalars and vectors. Scalars have a magnitude only, but the vectors have both a magnitude and direction. Velocity with the V is a vector with a V. How about weight with a double V? W, it gets you a vector again. Distance is a scalar, but displacement is not. Speed is a scalar, but velocity is not. Work is a scalar, but torque is not. First, let's learn about addition of vectors. Here's the first question that we have today. Suppose that we have a vector that goes in this direction, and this vector is 10 meters, and another vector that goes in this direction, and it's 5 meters. Can you add these two vectors together? Of course, 10 meters east and 5 meters east. 10 plus 5 is 15 meters. You have to say east, because vectors have a magnitude and a direction. So there you go, 10 meters, vector 1, 5 meters is vector 2, both of them are going east. Adding them together will give us 15 meters east in total. When you add vector 1 to vector 2, you get a resultant vector. The result of addition of vectors or subtraction of vectors is called the resultant vectors. You can also do this as if it's a number line. So let me have an orange color right here, and let's draw this 10 meters, okay, going east. And then let me grab a purple color and then 5 meters this way, okay? So this is called what? It's called tip to tail method. The tip of this one to the tail of that one. 10 plus 5 is 15 meters. So let me draw it like this. 10 plus 5 is 15 meters east. Here is question 2. Suppose that we'll have a vector going east like this, and it is 20 meters. And I also have another vector going this way, but this one is 12 meters west. Can you find the magnitude and the direction of the resultant vector? Sure. How do you do it? The resultant vector equals vector 1 plus vector 2. But you gotta be careful with the sign. Vector 1 has a positive sign because it's going to the right, but vector 2 has a negative sign because it's going to the left, and the rest is history. V1 is 20 meters, and V2 is not 12, but negative 12 meters. And the resultant vector will be positive 8 meters. Why plus? Because I'm going to the right. The resultant vector should look like this. 8 meters going east to the positive direction. And that's the resultant vector. You can call this process addition of vectors. You can also call it subtraction of vectors because it's 20 minus 12. As long as you get the signs right, you will answer it correctly. Just like here, 20 meters east, 12 meters west. What's the end result? What's the resultant vector? 20 minus 12 is 8. You can say 20 minus 12, or you can say 20 plus negative 12. It's the same thing. Why does this one take a negative sign? Because it's going west. Why does this one take a positive sign? Because going east, just like this one. Positive for east. We can call this addition of vectors or subtraction of vectors. Now here is question 3. The first vector that I have is 12 meters north, and the second one is 20 meters south. Can you give me the resultant vector of these two? Sure, the resultant vector equals vector 1, the orange, and vector 2, which is the purple. The first one will give it a positive sign because it's going north, so plus 12 meters. But the second one, be careful, it takes a negative sign because it's going south, minus 20 meters. You do the math, 12 minus 20 is negative 8 meters, and that's the resultant vector. If you want to draw it, it will be like this, negative 8 meters going south. So when something is going north or going east, it takes a positive sign. But when something is going south or going west, it takes a negative sign. Just like here, 12 meters north, that is positive, but 20 meters south, that is negative. So the end result is negative 8 meters, or simply 8 meters going south. It has a magnitude, it has a direction, because it's a vector. Question number 4. Here you have vector 1, vector 2, and vector 3. Can you draw the resultant vector, i.e. the result of the addition of all of these 3 vectors? Please pause. Okay, so imagine that Adam walked this way, and then walked this way, and then walked this way. What's the end result? Well, the end result is that Adam walked this way, from the tail of the first vector to the tip of the last vector, tail to tip method. And this is the direction of the resultant vector. For example, if I walk this and this and this, the displacement, remember displacement is a vector, not the distance, but the displacement. The displacement is from this point to that point, and the direction is going north. If you wish to see more physics videos in the future, please drop a car emoji in the comments. Next, let's review Pythagorean theorem. Okie dokie, here is my right-angled triangle. Beautiful. This is A, this is B, and this is C. You know that the hypotenuse squared, so C squared equals A squared plus B squared, just like that. Or you can say that A squared plus B squared equals C squared. It's the same thing. Now let's focus on this equation right here. What if I want C alone? Oh, so you want the square root of this side and the square root of that side. So the square root of C squared is just C. The square root of the other side is the square root of A squared plus B squared, and this is how you find C. Just like that, here is A, here is B, here is C. The square root of C equals the square root of A plus the square root of B. This is the sum of the squares and not the square of the sums. And then if you want C, square root here and square root there, as you see here. Now, whether you're studying mathematics, geometry, trigonometry, chemistry, physics, you name it, the following trick is going to save you a lot of time on your exam. This trick is to memorize the triples of Pythagoras. For example, if A is 3 and B is 4, what is C? It is 5. Because you square 3, you get 9. You square 4, you get 16. 9 plus 16 is 25. Square root of that is 5. What if A was 5 and B was 12? Then C will be 13. And these are called what? These are called Pythagorean triples. So let's memorize them. I have 3 and 4 and 5. I have 5 and 12 and 13. Do we have more? We have tons of them. There is 8, 15, and 17. There is 7 and 24 and 25. There is 20, 21, 29. Also, you have 12, 35, 37, 9, 40, and 41. And rhyming with it is 11, 60, 61. And there are many, many more, but these are the most famous. So 3, 4, 5, that's the easiest one. 5, 12, 13, and then 8, 5, 17, 7, 24, 25. So look at these consecutive numbers. 20, 21 are also consecutive. 40, 41 also consecutive. 60, 61 also consecutive. And here is a chart containing the Pythagorean triples that will show up on the exam. The most important ones are this column. If you are a pro, you can memorize this one as well. But if you can memorize this, you'll be in a very good shape and it will save you a lot of time on your exam. Time is money. Time is points on your exam. You can download these wonderful, colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Now here's question 5. This is the same question of the last video. Adam walked 3 kilometers east, then 4 kilometers north. What is the distance and what is the displacement? Please pause and try to answer it yourself. So this gluteus maximus walked 3 kilometers east. So here's 3 kilometers going east. And then walked 4 kilometers north. Here is 4 kilometers north. Okay, then what? We want the distance and the displacement. What is the distance? The distance always equals d1 plus d2. You just add up all the quantities, all the magnitudes, because distance does not have any direction. 3 here and 4 there equals 3, where is the purple color, plus 4, and the end result, before you know it, is 3 plus 4 is 7 kilometers. East, west, north, south, I don't care because this is distance. Now when it comes to displacement, forget this and forget this. I want the tail of the first to the tip of the last, which means I need to draw something else. I need to draw this. Oh, that's the displacement. And how much is that? Well, this is a right angle triangle. Oh, Pythagoras, baby. Exactly. So if I want C, okay, so C, let's call that the displacement. It equals the square root of, where is my purple color? 3 squared plus 4 squared. And we memorized that the triangle is 3, 4, and 5. X is 5. You can also do the math. 5 what? 5 kilometers. Going in which direction? Northeast. Distance is a scalar, but displacement is a vector. Distance has a magnitude only, but displacement has a magnitude and a direction. And that's why I love Pythagoras so much. If you actually want to know what Pythagoras ate in a day, I have a video on that called The Diet of Pythagoras. So there you go. Distance, 3 kilometers plus 4 kilometers is 7 kilometers. But displacement, now I want this. And this is the difference between the initial point and the final point. Final minus initial. How much is that? This is Pythagoras, 5 kilometers northeast. Easy peasy, lemon squeezy, medicosis schmeezy. Question number 6. What is the magnitude of the vector with the following components? The x component is 7 meters per second and the y component is 24 meters per second. What is the answer? Please pause. Well, that's easy. The x component is always horizontal, so this is my 7 meters per second. The y component is always vertical, and this right here is my 24 meters per second. Okay, what is the displacement? They're asking about this right here. This is the displacement. This is the main vector. These are the components of the vectors. This is the x component, and that's the y component. How much is that? We memorized that 7, 24, and the last side is always 25. If you're not convinced, you can do it like this. This vector, let's call it x. X equals the square root of 24 squared plus 7 squared. When you do the math, you will realize that x equals 25. 25 what? Meters per second. Is this a vector or a scalar? It is a vector, so I need to say the direction. It is 25 meters per second northeast. Just like that. Here is 7, here's 24, and this has to be 25 meters per second because this is a vector. I have to say northeast. Now look at this. This is the first triangle, and the second triangle, and the third triangle. Here's the first vector, the second vector, and the third vector. And each one of these vectors has an x component and a y component. And this is called splitting the vector into its components, an x component and a y component. Let's add these three vectors together. v1 plus v2 plus v3, you get all of this. Oh, and this is the largest vector. This is the resultant vector. That is the result of the addition of v1 plus v2 plus v3. And yet this one again has an x component, which is made of x1 plus x2 plus x3, and a y component, which is y1 plus y2 plus y3. After we finished addition of vectors, let's talk about subtraction. There is nothing new. You already know it. It's just like addition. If A is going east and B is going west, so it's A plus minus B or simply A minus B. You can call this addition of vectors or subtraction of vectors. The end result is always called resultant vector. Just like that, 20 meters east and 12 meters west. You can call this addition, 20 plus minus 12, or you can call this subtraction, 20 minus 12. Or like this, 12 meters north, 20 meters south. You can say 12 plus negative 20, or simply 12 minus 20. You'll end up with the same thing, negative 8 or 8 meters going south. We're done with addition, we're done with subtraction. Now let's talk about the heavy stuff, multiplication of vectors. We can multiply a vector by a scalar or a vector by a vector. First, let's talk about vector times scalar. This is how you do it. Here's the vector multiplied by a scalar. When you multiply vector by a scalar, you get another vector. For example, you will recall that velocity equals what? It equals displacement over time. Which means if I do the cross multiplication method, displacement equals velocity times time. Okay, now what? Here is a vector multiplied by a scalar, and what do you get? You get a vector. Bingo. A vector times scalar will give you another vector. Vector, of course, has what? A magnitude and a direction. How to know about the magnitude of the resultant vector? Easy. Give me the numbers only. Forget about the directions, forget about signs, make everything positive. Give me the magnitude of V1 and the magnitude of the scalar. I don't want any charges, I don't want positive or negative, just the amounts. Just the magnitudes, okay? You multiply these numbers and you get the magnitude of the vector. For example, suppose that this was -2 and this was 3. Forget the negative, just get the 2, get the 3. 2 times 3 is 6. That's the magnitude of the resultant vector. Okay, this is how I get the magnitude of the resultant vector. But how about the direction of the resultant vector? Because as you know, the vector has a magnitude and direction. To get the direction of the resultant vector, look at the sign on the scalar. Was it a positive sign here or a negative sign here? If it was a positive sign, then the resultant vector is in the same direction as the original vector. In other words, both of them are pointing towards the same direction, which means both of them are parallel. But if the sign next to the scalar is negative, it means that the resultant vector is moving in the opposite direction to the first vector, which means they are anti-parallel to one another. Let's practice. Here is question number 7. If a vector v1 is multiplied by a scalar +3, then the magnitude of the resultant vector is what? Is it A, equal to the magnitude of v1, or B, exceeds the magnitude of v1 by 3, or C, is triple the magnitude of v1, or D, is a third of the magnitude of v1? Please pause, think about it, and try to answer it yourself. Okie dokie. So the first vector is v1, and the scalar is +3. To get the magnitude, you forget everything about the charges. Forget this plus right here. Just give me the 3, okay? So it is v1 times 3. To get the magnitude of the resultant vector, you multiply the magnitude of the first vector with the magnitude of this scalar without any charges, okay? Then what do you get? I get 3 multiplied by the first vector, which means that v2, the resultant vector, equals what? Equals 3 times the first vector, which makes C the correct answer, because the resultant vector is 3 times as big as the first vector. And here's how you do it. v2, the resultant vector, is v1, the original vector, times s. Get the magnitudes only, multiply them together, you get 3s. This tells you about what? The magnitude only, not the direction. Now let's try this one. Here is question number 8 for you. If a vector v1 is multiplied by a scalar +3, then the direction of the resultant vector, or v2, is what? Is it parallel to v1, anti-parallel to v1, perpendicular to v1, or there is no relation in the French toast to v1? Please pause and try to answer this yourself. Well, how do I do this? Well, you look at the sign next to the scalar. Oh, it's a positive sign, which means what? It means that v2 is in the same direction as v1. Both of them are parallel to one another, making A the correct answer. Because if the scalar has a positive sign, then v1 and v2 are in the same direction, #parallel. But if the scalar had a negative sign, then v1 and v2 will be anti-parallel, opposite direction. How about this one? This is question 9 for you. If a vector v1 is multiplied by a scalar, -3, then the resultant v2 is what? Triple the magnitude of v1 and parallel to it, or is a third of the magnitude of v1 and parallel to v1, or is triple the magnitude of v1 and anti-parallel, or is a third of the magnitude of v1 and anti-parallel? Please pause. Okie dokie. In order to answer this correctly, you need to separate the magnitude from the direction. Think about one problem at a time. If you try to think about both of them together, you will screw it up. So just pause, take a breath, and let's focus on one problem at a time. First, the magnitude. Okay, here is v1 and here is this. Forget the charges. When it comes to the magnitude, I just want the amount. I want the magnitude without the direction. So basically this is v1 multiplied by 3, which gives me 3v1, meaning the resultant vector is triple the first vector. So it has to be triple the magnitude of v1, which means A is possible, B is impossible, and D is impossible. It has to be triple the magnitude of v1. Okay, so I eliminated 2 choices. Now what? Now I want the direction. Okay, how do I do this? You look at the sign next to the scalar. It's a negative sign, which means that the resultant vector is anti-parallel to V1, making C the correct answer. So when you multiply a vector with a scalar, you get a vector. This resultant vector has a magnitude and a direction. The magnitude, just multiply the magnitude of V1 and the magnitude of the scalar. Forget any charges, just the magnitudes. You'll get the magnitude of the resultant vector. To get the direction, you look at the sign next to the scalar. If it was positive, then V2 is in the same direction as V1. Hashtag parallel. But if the sign here is negative, then the direction of V2 is the opposite of the direction V1. Hashtag anti-parallel. So we just multiplied a vector by a scalar. Now let's multiply a vector with another vector. By the way, here is a very important point. When you multiply a vector by a scalar, what do you get? You get a second vector. But when you multiply a vector by a vector, you can either get a third vector or you can get a scalar. Example, look at this. Look at multiplication of the force, which is a vector, by displacement, which is a vector. Multiplying them together gives me work, which is scalar. Okay, but look at this. Here is a vector, force, and here's the lever arm, sometimes abbreviated R. So here is a vector and a vector. Multiplying two vectors together here gave me torque, which is a vector. So vector times vector is scalar, or vector times vector is vector. But what's the difference? The difference is what you do to the angle between them. If it is a scalar, you do vector 1 times vector 2 times cosine the theta, the angle between the two vectors. But if the result is a vector, you do vector 1 times vector 2 sine theta, not cosine. This right here is called the dot product, which means V1 dot V2. What does that mean? V1 multiplied by V2 multiplied by cosine theta. And this gives you a scalar. But here, when you do vector times vector to get a vector, it is V1 cross V2. It's a cross product, not dot product. What do I mean? V1, V2, sine theta, not cosine theta. This scalar, of course, has a magnitude only, not a direction, okay? But a vector has a magnitude, which you will get from this equation, and a direction. How do you get the direction of that vector? By the right-hand rule, like this. If V1 is going up like this and V2 is moving to the left, then the resultant vector is moving towards you. Next, multiplying scalars, like here's the first scalar times the second scalar, is commutative. Meaning you can say S1 times S2 or S2 times S1. No one cares about the difference. It's the same thing. However, multiplying vectors is non-commutative. V1 times V2 is not necessarily the same as V2 times V1. What does commutative mean? It comes from co-mutation. Oh, mutation, S1, S2, or you can mutate it into S2, S1. I don't care, but here I do care about the order. Question number 10. Try this one. What is the magnitude and the direction of the resultant vectors from the following cross product? Z equals A times B and L equals B times A. See how I did it? It's non-commutative because these are vectors being multiplied with one another. And A, x equals negative 2 newtons, y equals 0. But in B, x equals 0, y is positive 5 meters. Please take a moment to pause and try to answer this yourself. Okay, how do we do it? Remember, vector times vector can give me a scalar, which is not what we're trying to do right now because they told me the resultant vector has what direction and what magnitude. So they want the result to be a vector, which means they are talking about this, V1 times V2 sine theta. How do I remember which is which? Because scalar has cosine, but the vector has sine. Easy. I have a mnemonic for the scalar. Look, the scalar has a Q sound, so scalar is cosine. How about the vector? Oh, I am a vector. You are a bunch of losers, but I am a vector. So if you need the vector, you say I. I'm joking, of course. Here's the deal. Do not try to memorize two opposite mnemonics because on the exam day, you will mix them up and screw it up. Instead, just memorize one mnemonic for one, and then the other one's the other one. This is how I do it. I remember that I am a vector. So if I need the result to be a vector, I have to put the I, so sine theta, which means the other one is the other one. So let's do it. First, let's answer this question for Z equals A times B. And then in the next slide, we will answer L equals B times A. Okay, Z equals A times B. Okay, this is what? This is a cross product because the resultant is a vector, not a scalar, which means it has to be the first vector, the second vector, sine theta. What's your first vector, please? So here is A. X is negative 2 Newton, which means it's going south, but y is 0. What does that mean? If I draw my 4 quadrants like this, x is going in the negative direction. Okay, on the x-axis, I want to go negative. So here I go until I reach negative 2 newtons. Okay, did you go up or down? Well, look at the y. The y is 0. I did not go up. I did not go down. I just went negative 2 newtons. Okie dokie, just like that. Perfect. And where is your B? Well, B, x is 0, so I did not move left or right this time, but I moved up 5 meters. So let me get a blue color or a purple color, and let's go up 5 meters. I went up here. Okay, that's positive 5 for me. So this is positive 5. Sine theta, the angle between the two. What's the angle between the two here? Oh, one is going left, one is going north. It's a 90 degrees. And what is sine 90? Answer is 1. So just multiply positive 2 because I want the absolute value. So 2 times 5 is 10. 10 what? Newtons times meters equals Newton meter. Okay, so that's the magnitude of the vector z. But what's the direction of that? You get the direction using the right-hand rule. Here's the first component. The first component is negative 2 on the x-axis. I'm going negative 2 here. Okay, so how about this? Oh, it's the same. It's following the same direction as the negative 2 newtons. Okay, how about the direction of B? B is going up 5 meters. Up like this? Perfect. If you use your right hand, make your thumb look to the left, make your index finger look up, and you will find that the rest of your fingers or the palm of your hand is facing forwards. The direction of the vector Z is going into the page, away from you, and not coming out of the page at you. Next, let's answer the second component of the question. L equals B times A. All right, what is B, please? B is positive 5, as you see. And what is A? A is negative 2, as you see. Let me draw the 4 quadrants to be sure. Now be careful, they want B before A. Okie dokie, so I want the positive 5 before the negative 2. Let me draw the 4 quadrants like this. I want the positive 5 first. X is 0, but y is positive 5, which means positive 5 on the y-axis. Let me draw this here. That is my positive 5 meters. And then what? And then you go to A, which tells you negative 2 on the x-axis. Here's the x-axis. I should go negative 2 right here. Nice. Which one should begin first? Remember that when you use the right-hand rule, V1 is always in the thumb. The thumb is always for the first vector, and the index is always for the second vector, and your 3 fingers are always for the resultant vector. So where's the first vector here? B before A, so B is the first one. Where is B? It is the positive 5 on the y-axis, so my thumb is pointing up. Where is A? It is negative 2 on the x-axis, so my negative 2 here, it's looking negative, just like the negative 2 on the x-axis. And when you do this, you will find that the 3 fingers are pointing towards you, coming out of the page at you. And this will be the direction of L vector. So both the Z vector and the L vector have the same magnitude of 10 n times m, but they have a different direction. Z was going into the page away from you, but L is coming out of the page at you. Please, for the sake of decency, do not use your right-hand rule in your teacher's face. It will be misunderstood. Next, let's review some trigonometry. Remember, this is the resultant vector. You can split it into its 2 components, the x component on the x-axis and the y component, the y-axis, horizontal and vertical. And the angle here is called theta. What's that? That's the angle theta. And this is the side opposite to the angle theta. This is the adjacent side to the angle theta. And what's that? That's the hypotenuse, which is always the opposite of the right angle. So K2 is the mnemonic. What is sine? Sine theta equals the opposite over the hypotenuse, like this, which means what? How about the inverse of sine? It's called the cosecant theta. Is what? Is the inverse of sine. Instead of opposite over hypotenuse, it's hypotenuse over opposite. You can say cosecant theta, you can write it like this, you can write it like this, or you can write it like this. I don't care. Next, cosine theta is the adjacent over the hypotenuse, just like that. Therefore, what's the inverse? The inverse of cosine is the secant. And you can write it like this, secant theta, or sec theta, or cosine power -1 theta. I don't care. It's the inverse. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Last, the tangent of theta is the opposite over the adjacent. Opposite over adjacent, or the rise over run. Rise over run is the tangent of theta. What's the inverse? It's called cotangent. You can write it like this, or like this. It's the opposite, the inverse. Adjacent over opposite. So, as you write it like this, sine power -1 theta is the inverse of sine theta. This is the cosecant, but this is the secant, which is the inverse of cosine. And this is the inverse of tan, known as cotangent. Believe it or not, sine theta is the exact same thing as cosine 90 minus theta. For example, sine 30 equals cosine 90 minus 30 is how much? 60. So sine 30 equals cosine 60. Sine theta equals 1/2, and cosine 60 equals also 1/2. So let's apply this to vectors, okay? Here is f, here is my vector. It has an x component and a y component, all right? If f is the unknown, how can I find f? Pythagoras, baby. F equals the square root of fx squared plus fy squared. That's easy, because c squared equals a squared plus b squared. Okay, what if fx is the unknown? To get fx, you need f cosine theta. So you multiply this by cosine of this angle. I don't get it. Remember that cosine theta is what? Cosine theta is the adjacent over the hypotenuse. Remember SOHCAHTOA? S-O-H. C-A-H-T-O-A. Cosine theta is the adjacent over the hypotenuse. What's the adjacent to this angle? It's fx. And what is the hypotenuse, please? It is f. So you know this already. Yeah, if you want fx, cross multiplication, fx equals f cosine theta. And this is how you do it if fx is the unknown that you need to know. You multiply f times cosine theta. But how about the sine? Sine of theta equals the opposite, which is fy, over the hypotenuse, which is f. Cross multiplication, fy equals f sine theta. If cross multiplication is difficult, just multiply each side of this equation by f. So it becomes f sine theta, and this becomes just fy. So this is how you do it if f is the unknown. This is how you do it if fy is the unknown. And this is how you do it if fx is the unknown. How about if theta is the unknown angle? Well, since tan theta equals rise over run, fy over fx, then the inverse, the cotangent is the inverse, fx over fy. Then theta is what? Theta equals the cotangent. You have to inverse it again if you want theta alone. So you reverse it, equals fy over fx. How do I remember which is which? Because I can mix sine and cosine up. Well, you can get it from its origin, from this mnemonic. Or if you want another one, look, here is f of x. It has a q sound, and this is cosine, has a q sound. But f of y is sine theta. Y, I. So y goes with I, and the q sound goes with the q sound. Again, please do not try to memorize two opposite mnemonics, because on the exam day, you will screw them up. Instead, just memorize one, and therefore the other one is the other one. I memorized this one. F of y is the sine theta. I is y, and therefore the x is cosine. Question 11. If fx equals -40, fy is -30, calculate f. Please pause and try to answer this yourself. How can I do it? Well, first you draw the x component. It is negative, so it's going this way, and this is -40n. Then y in the y-axis, or the vertical direction, it's -30. So it is decreasing, going down, going south, -30 newtons, like this. What do they want? They want f. They want this doofus right here. Okay, how do I find this? Since this is a right angle, you can use Pythagoras, which means f equals the square root of -40n. You square this, plus -30 newtons, and you square this as well, and you find that f equals, you have memorized that it is 3, 4, and 5, or 30, 40, 50. Same thing, so 50 newtons. But remember, this is a vector, so I need a magnitude and a direction. What's that direction, please? It is going southwest. This is the same answer in color. You go -40 in the x direction, then -30 in the y direction, and you're trying to find f. This is Pythagoras, easy. It's going to be 50 newtons southwest. Now, the following questions are your homework. Please try to answer them. Let me know your answers in the comments, and you'll find the answer key in the next video, where we talk about distance and displacement. Here is question 12. This is question number 13. Here is question 14. And here's the last question, question 15. Here you have all the equations that we learned about today. The resultant vector is vector 1 plus vector 2. You can say addition or subtraction. Be aware of the sign or the direction of the vector. When you multiply a vector by a scalar, you get a vector. But when you multiply a vector by a vector, well, it depends. You can get a scalar. Remember, the scalar with a Q sound is cosine theta. But I am a vector. If you want a vector, say I. Say sine theta. We talked about Pythagoras and we talked about trigonometry, how to find f, how to find fx, how to find fy. Remember that I is y, but the Q sound, cosine, is x. And how to find f by Pythagoras, how to find the angle. If you want to download all of my physics notes, general chemistry notes, organic chemistry notes, biochemistry notes, physiology notes, I have all kinds of notes on my website, medicosisperfectionalis.com. If you want to learn about glomerular filtration rate or GFR, the proximal tubule, the loop of Henle, the distal tubule, etc., download my kidney physiology course at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.